The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, problem 19. A satellite A is in orbit a distance r above the surface of the planet of radius r. A second identical satellite B is at a distance of 2r above the surface. What is the ratio of the forces due to the planet on the satellites? FA over FB. So, in this problem, we have planet, radius r. We have one satellite, A, at a distance from the surface of the Earth, or of the planet, of r, and we have another one at a distance 2r, b. They want to know is basically FA over FB. So that's what we're going to be solving for. So this problem, we just need to figure out the force between the planet and the satellites. Either of the planet on the satellite or the satellite on the planet, depending on how you want to look at it. So basically, anytime you're dealing with these problems with planets and satellites and planets and stars or two planets or anything big and you're looking for force, we're not going to use our F equals ma or do any of that. What we need to do is we need to go to our true force equation. F is equal to G times m1, m2 over r squared. Okay, this is how you actually calculate the force between two objects of mass. Now they tell us that satellite A is identical to satellite B. So what we can do is we can say that they have the exact same mass. So what I'm going to do is I'm going to designate the mass of this planet as our capital M, and the mass of each of these satellites, which is identical, to be a lowercase m. Right. We have to work in variables for this one because they don't give us any numbers and they're asking you for a ratio. So, FA. So we have a gravitational constant G, for the mass of the planet, the mass of satellite A, over the distance. Now this is the one part where they can trick you in this problem, is the distance that you use for r is going to be the distance from center of mass to center of mass. And they purposefully tell you these problems almost every time where they give you the distance between the satellite and the surface of the planet, just to try to get you to use that value, which is never going to be the right answer. You have to include the distance from the center of mass to center of mass. So we have to go from the center of the planet, a radius r, to get to the surface of the planet, and then another radius r to get to the satellite A. So what we're going to do is we're going to plug in 2r in the denominator and then square. And don't forget, you have to square both the 2 and the r. If you write a 2r squared down in there without squaring the 2 and just leave it like that, that's going to give you a wrong answer every time. So this gives us g, big M, little m, over 4r squared. Alright, that's FA. FB would be basically the same concept. Same mass, you don't have to worry about that. Now, the difference is this one's 2r from the surface, so we have to add that extra r to get to the center of the planet. So we're going to have our 3r, and that's all going to be squared. So we end up with g mm for 9r squared. Once again, make sure you square the 3 and the r. From there, all we have to do is take FA and divide by FB. So, write this out. FA over FB is going to be G mm over 4r squared over G mm 9r squared. So you can see a lot of common variables, so we can cancel all those out. Little m's cancel, big m's cancel, g's cancel, r squareds cancel. What we're left with is 1/4 divided by 1/9. Alright? Don't let this confuse you. If you have a calculator and you're not good with fractions, just punch it in. Don't feel bad about it. Just make sure you actually use your parentheses right. If you can figure it out, then this is going to be the exact same thing as saying 1/4 times 9/1, which is just 9/4, which is 2.25. So our ratio, FA over FB, is 2.25. And that's going to be our final answer, choice 1.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.